Hey, good evening to all of you. Can you please confirm in the chat that I'm audible to all of you? I'm audible and you're able to see my screen. Can you please confirm that? Okay. Fantastic. So I see there are a few people still joining. I hope you had the chance to look at my earlier session, which was on Docker. Can I hear some feedback about the last Docker session which I have taken? How did you like it? Was it informative? By any chance, did you get any benefit out of this? And if you haven't seen that session, my team is going to share the URL. I would say it was one of the best sessions on Docker I have taken in the recent times. A very good introduction to what is Docker, how is it similar and different than virtualization. Basically, we compared containerization and virtualization. We then moved on to understanding the Docker architecture, the taxonomy, and then we also covered creating a simple Docker image, uploading it to the registry, downloading it and creating the instance of it. So those who haven't seen this particular session, I would strongly recommend you to look at it. It's really a very good introduction to Docker. Even I was kind of very satisfied after taking this particular session. Those are some moments where we know we have done very good job, right? So Docker was one of that session. After the session was completed, I was so satisfied that yes, it really went well. And I believe the team has actually created a playlist out of that particular session and they would share with you on the chat. You can pick it up from there. Can I know if anybody is here who is attending my class for the first time? Or if you have been attending in the past, what is the kind of experience you have received? And do you have any kind of suggestions, feedback, so that we can further improve these kind of interaction? Do you have any topic which you want me to pick up for you? Or in general, I would say if you have any kind of questions, you can post it there. I'm just trying to borrow some time so that I can start the session. And I'm telling you, this is again going to be one more extraordinary topic which is going to add a lot of value, especially if you are coming from the developer background or DevOps background or something similar. And yes, I see some people specifically mentioning certain points about if something has hit you hard in the session, document it. Even in today's session for that matter, guys, I can request you people to listen to the class, and if you have heard of something which is worth noticing it, type it on the chat and post it. Others will also realize, oh yes, this was something important. That way you're actually contributing to the class. You're not just receiving it, you're also giving a bit of it to the class. It's always really a proud feeling to be on the side which is giving. So the way you in this particular session can contribute is you liked a particular sentence from my class, you heard this for the first time, or something has hit you hard. Oh yes, wow movement. Type it on the chat and post it. They get recorded. And others would probably also realize, yes, this was something important. And I would also know that, yes, you are taking the benefit out of these particular sessions. Don't forget to put in the chat your past experiences with Deccansoft and what you want to hear from me in the future sessions. I have decided 2 or 3 topics, but there is a series of topics which I can actually take. Huge number of topics which out of my experience I can deliver to the class. So yes, if you feel there is something which I can add value, go ahead and I'll be glad to deliver that in the future sessions. Session on Azure Service Fabric. Azure Service Fabric is outdated. Instead, I'm going to plan some sessions on Kubernetes. Nobody in the industry uses today Azure Service Fabric. But yes, Kubernetes is something which is popularly used by the people in the industry, and we are going to have some sessions on Kubernetes. Some live projects. Yeah, let us see if I can probably bring forward for you people some projects which are completed by my development team and demonstrate to you the entire power of Azure. So let's see. Yes, definitely that is on the cards, and whatever best possible I'm going to do. 4 more minutes, I should be able to start the session. Just 4 more minutes. In the meantime, feel free to put whatever you like on the chat. Don't forget to hit the like button whenever you feel something you got out of this particular session. Do subscribe to the channel so that you can attend the future sessions also. Some very interesting sessions are going to come up on our website. Azure AI search, cognitive search, okay. We have 3 more minutes to go. Can I know from which places you are from, most of the people? Anybody from United States? I see 𝗗𝗏 heç''𝗙𝗹𝗹𝗁. She's one of my very old student. I'm not sure if she's the same. Anybody from India, Australia, Japan, United States, UK, Mumbai, okay. Feel free to share this session with your friends if they are online, or just share the link of this particular session so that they can also participate. As I'm talking to you, you can forward the link on your social media accounts, maybe WhatsApp, maybe Facebook, maybe whatever you use. Azure Data Factory, wow, fantastic. I think that's one thing which I don't teach, but Vandana teaches. I would definitely love to arrange one session on that. We'll do that. Ireland, Hyderabad, okay. Okay, so a lot of people from United States. Okay, it's time. 1 more minute to go and we should be ready. Trust me, 1 hour of solid content would be delivered to you. And every minute of it is going to be worth. I can give you that assurance. Just 1 more hour, 1 more minute, and 1 more hour. I am completely dedicated to you. Few seconds to go and we will be ready. This particular session is going to be on microservices architecture. Basically, it is going to give you experience on why did microservices evolve, what are the benefits, what are the characteristics, and a little bit more about how the microservices applications are built. And this is just one session in the series which I am going to take. So yes, it's good time to start introduction to microservices. See, every application developer might use a programming language like Java, Python, .NET, PHP, Ruby, and so many other languages which are there in the industry. And we all very well understand every language has got its own power and edge in certain aspects over the other languages. And whatever language you choose, ultimately we are going to build applications using these programming languages. Applications can be desktop based applications, can be services which run in the background, can be web based applications, can be mobile based applications. There can be many services which are run on the server which can be consumed by various other types of applications and so on. Industry for quite some time, maybe I would say a decade back, for at least couple of decades, was majorly concentrating on building applications using an architecture which they called it as monolithic architecture. Now, what exactly is this monolithic architecture? You take one language, maybe Java, maybe .NET, it can be C++ also, and using this programming language, you create a project. And that project is going to comprise of code for different modules. And you ultimately build the project and run the project. So monolithic applications are the one which run all in one process. Single program, single process in memory. Yes, many developers have used multi-layered architecture. They used one layer for presentation. They did all the UI stuff in the presentation layer. They built business layer where all the business logic would be written. And they have also created the data access layer. It's a multi-layered architecture, but all the layers are just logical separation. Physically, they are all going to run in a single process. And when they run all in one process, that type of application is referred here as a monolithic application. A monolithic application is a self-contained. That means everything required is part of that application itself and is independent from other applications altogether. You deploy the application individually, you run the application individually, everything runs in one single process. Just remember the keyword monolithic, huge, one process. So yes, as I said, you might divide the monolithic application into UI layer, business layer, data access layer. UI layer will be responsible for taking care of the HTTP request, or sometimes it can be input in JSON format or XML format, and same thing for output. And at times the UI layer can also be built using something like XAML. if you are working with the WPF application or Windows modern applications. And then your business logic, the rules of the business will be implemented and data access will be done in the data interface layer. But this is multi-layered, this is not multi-tier. Once the application is developed, we know that there are multiple ways of deploying. How to deploy a monolithic application? It's a single project. The language is going to provide you a facility where you can publish the project. When you do publish, basically it will do a build and generate output, which I can probably zip it or package it like a setup and deploy on the target machines. These target machines can be on-premise physical machines, or they can be even virtual machines which can be in on-premise, or nowadays it can be in the cloud. So you create a project, you build a project, you publish a project, and you deploy the project. That is one way of doing it. And the other way of doing it is, a lot of people have been using containerization. Like I explained in my previous session, how Docker containers can be used. Yes, we might probably build entire application as a Docker container, which is going to include all the dependencies required for execution of the application, and there is no need of third-party dependency additionally. The images would be created, placed into the registry. From the registry, they would be pulled, and the containers can be created in different environments, which can again be PaaS services in Azure, like app service, or it can be a virtual machine or EC2 instance in AWS, or there can be so many other kind of compute services where directly we can create containers and make them work. Easiest and simplest way of distributing applications. All good. What are the benefits? They are easy to develop. You just need to know one programming language, master the language. The team will master that same language, build all the features in that. They're simple to test because the test cases can be written in such a way that you make a call to the functionality, you get the response, compare the response with the expected output, and if it matches, the test case passes. If it doesn't match, the test case fails. You might even go for something like Selenium testing. If you want to build a UI based application, you might do a Selenium test case, which can be done in Java, .NET now. Open source community has contributed enough to that also. Simple to deploy, like I just now explained. You just need to build an image and deploy the image in the registry, and from the registry you need to pull the image and create containers, or maybe simply run the setup project on the target machine. Simple to scale, especially when you are doing Docker. The only thing you'll have to do scaling is replicate the entire machine, and after replication simply put the load balancer between them so that the load can be distributed on different instances. So you can easily scale the monolithic application. Yes, these are the good aspects of monolithic application. But if the industry was always happy with monolithic application, it would not have evolved to the microservices based application. Definitely with time, when the industry expanded, the technology expanded, internet became so popular, we wanted to now move on to the modern applications which we should be able to deliver faster. Everything is fast nowadays. We want quick results nowadays, and that's where the microservices evolved. But before I get into microservices, I would like to take your attention on the drawbacks of monolithic architecture. At least out of 27 years of my experience in the industry, I would say more than 15 years even I was involved in building monolithic applications only. But then of late, we started identifying problems with these. What are the problems? Monolithic, one single block. In that project only, all the modules of the applications are going to be programmed. Let it be login module, let it be about us module, or if you're building something like a e-commerce based application, let us say your product catalog module, your shopping cart module, payment gateway module, feature products module, everything is going to be part of one single project. With time, the project is going to get larger and larger. That means the code is only going to get more and more. And as the code gets larger, obviously it is going to get complex. And because its complexity is increasing, it is going to be very difficult for any newcomer who is going to join the project to fully understand all the aspects of the project before they start making any kind of changes or if they want to add any kind of new feature. Huge amount of time will be taken in refactoring the code, understanding the already existing code before they make any tweaks or changes to the code. And that's one of the major drawback the industry has seen with monolithic application. With time, they get larger and thus they get complex. Applications will have some startup code. Basically, some kind of initialization will be required. Monolithic is all in one process. When everything is in one process, it's going to be again taking time for the initial code to execute. For each and every module that code has to be loaded, that means the initial startup time will be very high. This is going to give a really negative impact to the end user, especially when the application restarts. Yes, startup time is a concern in monolithic applications. Doesn't give a good user experience because there is a delay in what they see for the first time. Because it's a single block, a small change in one part of the application, small change in one part, you will have to rebuild the entire project, and when you say rebuild, you'll have to redeploy the entire application. And this can at times lead to some kind of downtime also in some special circumstances. Downtime for the application implies downtime for the business. Downtime of the business implies loss to business. Because there is so much of code and so much of it is well interconnected to each other, you may not end up writing only automation testing. You might have to do a lot of manual testing also. Worst problem is a small bug in one module. Something like a memory leakage, stack overflow happening can lead to bringing down the entire process. The whole application will go down. Imagine a case where I have problem only in order management module of the project, but I'm not even able to display the product catalog to the user. Why not? Why not let the user continue to manage the product catalog, add items into the shopping cart, but probably for a short period of time, they're not able to place the order instead of entire application going down. That problem is there in monolithic because it's a single process. Earlier I said it's simple to scale. Now I'm saying difficult to scale. Why? When I'm scaling horizontally, every module of the project is scaled equal number of times. But we pretty well understand that product catalog, I may need more number of instances running to distribute the load than probably shopping cart, and shopping cart instances will be more when compared to probably order management, because very few people might go from catalog to shopping cart to order and let's say to the payment gateway. But in monolithic, because it's a single process, equal number of times the entire process has to be replicated, and that can lead to wastage of memory and processor. That's again a big drawback of monolithic application. Monolithic applications have the biggest disadvantage of inability to adopt new technologies. Way back, sometime in maybe 90s, I might have used .NET framework. Now, if I want to, let's say early 20s, early 2000, I use .NET framework. Now I want to upgrade to maybe .NET Core. Or maybe I know that some module is better if I do it in Python because that is where the AI and ML stuff is more powerful. I wouldn't be able to do that. Because it's a single process, single project, only one technology has to be used, one framework has to be used, and we are stuck with that. Even though at the time when the project started, that was the best, it may not be the best today. We might have better alternative languages, better features in different other languages, but we will not be able to exploit them or use them. So these are the main drawbacks which I have noted in monolithic application based on my experience in the past. Yes, each and every drawback which is noted here is going to lead to the evolution of better architecture today, which is most popular in the industry, most successful in the industry, and that is microservices architecture. Now, what is microservices architecture? In microservices based architecture, we are going to break a large monolithic. See, entire discussion on monolithic, you might have noted all the problems are because of one process. Everything is running in one process. Everything is running in one process. That's what I have been telling. So every problem in monolithic is just because everything is in one process. So think of it like one ship, cargo ship, and it can take only one item. It can carry only one item, maybe oil. Now with oil, I will not be able to take furniture. Or if it is all furniture, I will not be able to take something else. But now we are talking about microservices based architecture. We are going to break a large application and all its modules into different microservices. A large application is broken into small chop it. You have to chop it, small pieces. And each microservice, each one is a microservice here packaged in a separate container. So what is a microservices architecture? It's an architectural style, very important. It's an architectural style. Microservices is an architectural style that structures an application. The entire application is broken into multiple related services. Somewhere or the other they are related, but each service is developed independently, built independently, deployed independently, versioned independently, upgraded independently. Every service is independent of the other service in terms of development and deployment, but somewhere they share something in common, and one can be invoking the other with some standard set of interfaces or protocols. So this kind of architecture where each service is running in a separate process. Every microservice will have its own process. Unlike monolithic, everything is in one process. Every microservice, tiny, will be in a separate process. Developed separately, deployed separately, versioned separately, upgraded separately, and still they will be able to communicate with each other using some standard protocols. Such an architecture is called as microservices architecture. Yes, every microservice will have its own internal hexagon of multiple layers. Every microservice internally will have the user interface layer, the business layer, and the data access layer if needed. And there are many other architectural patterns which can be used for development. So yes, if monolithic architecture was majorly concentrating on user interface layer, business layer, data interface layer, it is here only all the UI of different modules would be present. Here only all the business logic of different modules would be present. Here only all the data access functionality of different modules will be present. And here all the tables related to all the modules will be present at one place. Unlike that, in microservice, for every module, we will have a separate microservice. Basically, we will have a large domain broken into multiple subdomain. We use something called as domain driven design, DDD, wherein a large domain is broken into multiple subdomain, and for each subdomain there is something called as bounded context which is created. A boundary is created. In that bounded context, there will be something called as application model which has to be created. What is application model? A collection of objects which are related with each other, most of the time using has a relationship. Something like category has a product. Product has a rating. So like this, a catalog module can be created. A catalog microservice can be created. So a microservice is a programmatic implementation of a subdomain of a larger domain, having its own independent code and its own independent database. Like that, every module or every subdomain you can treat as a separate microservice having their own database. See the dependency. If the database is different, obviously they are absolute independent of each other. The UI also is going to be developed as a microservice here. And there can be certain cases we build a microservice which in background will again connect to other microservices, a composite microservice. So everything in the project, your UI to security, to different aspects of the project, everything is treated as microservices, and the application architecture is thus referred as microservices architecture. So when monolithic pattern was in conflict of actually the containerization principle. Containerization principle always said that a container should do only one thing and it should do only that in one process and nothing else. So though for monolithic application we can use containers, we are deviating from that basic principle. In one container only, we are putting product catalog also, shopping cart also, payment gateway also, order management. One container is overloaded. So the very purpose for which containerization was introduced is defeated in monolithic architecture. Unlike that, in microservices architecture, for every microservice, we will have a separate container. It goes pretty well with the container pattern that each container should only do one thing and it does that in one process. Absolutely mapping perfectly to the microservices architecture. Guys, reminding you once again, if you are picking up some things, don't mind sharing it on the chat. As I'm talking, I will talk a lot of content. Whatever you have picked up so far, maybe small points, it's okay. Like as if it should be, you're chatting with me continuously. Whatever is your pickup, whatever is something which you said, wow moment, capture it. If you don't capture the wow moment, they will be lost. Life gives us many wow moments. We don't recognize them. We always keep cribbing, but the wow moments have to be recognized. We have to put some little energy on that wow moment. Then we become more and more happy. So in this particular session, the wow moment is something new you learned, record it. And how to record? Put it on the chat. And that's the return you are giving me back when I'm contributing the content to you. So go ahead and keep recording it. So yes, just a reminder once again, I still see there are only 12 likes. I believe by this time I deserve more better likes on the session. And at the same time, feel free to share it with others in your community. Even after the session is completed, the recorded version of this will be available online, and I would surely expect you to share it with others. Even if you are watching this session offline, feel free to comment it. I do read most of the comments on YouTube, and those are the motivations for me to come back again and again and deliver more such kind of sessions. Coming back to the subject. Now that we understand very clearly what is the difference between monolithic architecture and microservices architecture, how monolithic applications are different from the microservices based application, let's go a little more deep dive in understanding what are the characteristics of building a microservices architecture. But before that, just for a small better analogy, from browser, you are going to send a request to web server, maybe Tomcat, Apache, Nginx, IIS, Kestrel, and these web servers will have an application forwarding the request to the various microservices based application. This is monolithic. One process, multiple services. Another process, which is nothing but replication, horizontal scaling. All of this talking to a single database. This is what is monolithic architecture. Microservices architecture will be something like this. Each functionality is developed as a separate service. Account service, inventory service, shipping service. They can be any service. Every service is going to provide the functionality as REST API calls. Most of the time JSON input, JSON output. And of course, the developer will take care of converting the JSON input to C# or C# to JSON or JSON to Java, Java to JSON object. That serialization, deserialization is part of almost every language today. And every service will have its own database. So this is how you can visualize the major difference between a storefront monolithic application with a storefront microservices based application. Now let us say that you are a serious microservices based application architect. You are required to architect a solution now using microservices. With huge amount of experience in maybe .NET or Java or Python, you now want to move from monolithic to microservices architecture. What are certain things which you have to take care of? What are the basic aspects which we will have to take care of when we are building a microservices architecture? So you see the main bullets are all characteristics, and because of that characteristics, the sub bullets are the benefits. So I've combined here the characteristics and benefits of microservices. First and most important characteristic, the microservices application might be huge, but individually microservices should be small, relatively small, very small. Small to the extent that they should remain absolutely focused on the domain or the business functionality for which they are made. They should be confined to a particular context boundary. It should do only that, and it shouldn't do anything more. Precisely. That's what is the first characteristics. Benefit is obvious. Because the functionality is confined, developers will find very easy to understand the existing code and will be able to maintain, upgrade the code at any point of time with minimal investment of time. They don't have to understand huge code, no, small code. So it will be easy for them to understand the existing code and then develop and maintain small services. Obviously, it is going to be a domain specialist who will be able to work on a microservice. They learn more and more about that domain with time, and it will become very easy for them to evolve and release business features. Because they are confined to a small module, you get better testability. You are testing code in pieces, so you will end up testing faster, and definitely there is an improved fault isolation. If you know there is an error in this microservice, it is confined to that only. You don't have to go and search for the error connected at any other place. So first and most basic principle, or I would say characteristics, it should and must be very small and should be specific to a given domain, programmed in the context boundary. Good. At the same time, a microservice should not involve in development 100 developers at a time. No. Every microservice should have a small engineering team, maybe 3 developers, 4 developers, and that's it. And this team should be specialist in a particular technology stack. All of those team members together might use Java, or they might use .NET, or they might use Python. But good point is they should be focused only on that service in that particular technology, and they will have the autonomy to use any language of their choice, because eventually the microservice is going to be bundled like a container. Once it is bundled as a container, we don't have to worry about its dependencies. It's all taken care by the container process. Implies very simple, the engineering team or the project doesn't have to stick to only one technology stack. There is no long-term commitment. If something can be done better in new technology, choose that and develop it. So these are the benefits we get when we hire small engineering team for building a particular microservice. Every microservice is going to be deployed independently. You may have a separate CI/CD pipeline, separate repository for each and every microservice. The microservice for product catalog should have its own life cycle for development and deployment, and the microservice for shopping cart should have its own life cycle for development and deployment. So yes, deploying a microservice should also be independent. And how are they deployed most of the time? They're deployed as containers. And because they are deployed as containers, we don't have to take care of the dependencies on the target machines. Everything is bundled in the container. You can easily upgrade them independently. There will not be any downtime. Generally what we do is we do something called as rolling update. So there will not be any downtime for the microservices. Remember, the microservices based application is a distributed application. It's not going to run in just one machine, one process. It is going to run in a cluster of machines, a network of computers connected to each other with some built-in software. And on top of it, we are going to deploy the microservices. So it's a distributed application which can be spread on the entire network, and there can be multiple instances which are going to run so that we do not have downtime and we do rolling updates. It makes continuous deployment possible for complex applications. Microservices architecture enables services to be scaled independently. Beauty now. Product catalog, I might scale 10 instances. Shopping cart, I might scale 7 instances. Payment gateway, I might scale 3 instances. Order management, I might scale 4 instances. And more the number of instances, only that much memory and processor will be occupied. We are not scaling every instance equally and wasting memory and processor. Proper utilization of server resources is able to happen now. Every microservice is running independently, and because every microservice is running independently, there is no single point of failure. Rather, the database is also different for each one of them. Now, because if one database is not working, maybe the concerned microservice might stop working, the other microservices might still continue to work. That means if your application is going down, it is only a small aspect of it which might not work, function temporarily, and the team can work in bringing them up and make the entire application run without having complete downtime. Partial module downtime might be there. So yes, we shouldn't have a single point of failure in microservices. Every microservice compulsory should be resilient to failures. That means if something goes wrong to the microservice on one machine, or probably that machine itself has crashed, automatically we should be able to reinstantiate that in another machine on the network. Because it's a cluster we are talking about. So that also leads to resilient feature of microservice. No downtime. High availability can be achieved because of the resiliency of microservices for its failure. Need to have a unique name. One of the important characteristics. Every microservice must have a unique name. Then that is how the caller will be able to call the microservice. And because of that unique name, we can have hundreds of microservices being distinguished from one from the other. So most of the time, we are going to have a DNS in the cluster, which will take care of mapping the name to the corresponding IP address and ensure that the microservice is discoverable from the right location. And yes, every microservice runs in its own process and communicates with other using standard protocols, which are not native to any language, which are independent of the language and technology, like HTTP, HTTPS, WebSockets, AMQP, which is Advanced Message Queue Protocol. So these are all different characteristics and their respective benefits. And by this time, you should have realized why the entire world has already moved on to building microservices architecture. Yes, microservices is not something new anymore now. Lot of projects in the industry are already following this development architecture. And if I talk about the design principles, it's domain centric. As I told you, you should focus on a microservice specific to a given domain. Single focused, only one thing you should do at one point of time as a microservice. It should be developed independently, deployed independently, decoupled from others, and moreover, there should not be any direct communication also. You should preferably have asynchronous communication between microservices. So if one stops working, that does not mean the other will also get blocked. They should be decoupled, autonomous, deployed and scaled independently. resilient to failure, fail gracefully, and have a mechanism to implement retry logic. Because one time a request failed, it should not be declared as unsuccessful. There should be some retry logic which has to be implemented. And of course, every microservice should be discoverable, observable on a network. So these are the design principles based on which an architect is supposed to create a microservices based domain driven design for the application development. All these are companies which are popular because of their product. And the product is nothing but an application, software application. Amazon, eBay, Groupon, Netflix. What are these? Are they selling some product and because of which? No. Amazon is a platform which is built on top of microservices based architecture. Uber, Netflix, all these are platforms which are purely microservices based architecture and are able to scale to the extent they want. Increase in load, doesn't crash because it's not a single process. So success of these companies is purely because of they at the right time adopting microservices based architecture, and when the product became successful, they were able to distribute the load and not crash, planned for the future, and they have success stories today. And n number of such products are there which are today microservices based architecture. It wouldn't be right if I miss upon service orientation when I'm talking about microservices. A lot of people have confusion in the industry. You're talking, Sandeep, about monolithic. You're talking about microservices. What is this service orientation? In between, it was service orientation. Monolithic to microservice did not happen. It was monolithic to service orientation to microservices. That's how the transition happened. So if monolithic, we talk about a single unit. In service orientation, we break the application into different independent services. And these services are further broken now to microservices, fine-grained, coarse-grained, fine-grained. So service orientation is also a collection of services. Microservices, I said, is a collection of services. Service orientation is also a collection of services which are communicating with each other. And these communication can be one service calling the other service, passing the data to it, getting it processed there and getting the return value back. And sometimes one service calling multiple other services. Basically, service orientation did not give as much specification as we have today for microservices. Everybody developed services in the way they liked it. There was no standard or specification given for the success of the application. You might have heard of SOAP, Simple Object Access Protocol, which was used for building services and communicating with it. SOAP was heavy. SOAP was native. The SOAP protocols were not consistent in all the technologies. The implementation protocols which were built on top of SOAP maybe were supported in .NET, and those things were not invocable from Java. So there was no standard specification when service orientation was evolving in early 2000. And moreover, these services never communicated with their respective database. They used single database, single point of failure problem. And how do I know if a particular service made a change to the database and other service would not get impacted? No. So though we were using service orientation, we were still very close to monolithic. Everything was running in single process. Not that this service and this service were running independently in different processes. And moreover, industry used something called as enterprise service bus as a layer on top of services so that the UI programming can become easy. UI will talk to enterprise service bus. Enterprise service bus should do the job of routing or maybe invoking the services, consolidating the result and giving it to the UI. That was supposed to be the job of enterprise service bus, but people misused it. They started writing so much code in enterprise service bus that business got implemented here rather than actually getting implemented here or here. So the very purpose of moving from monolithic to service orientation got defeated when people started writing logic, business rules in enterprise service bus layer. Definitely not something expected, but that happened because of the common database, common service layers, and blah, blah, blah. Such things are not the case in microservices. They are clear domain-driven design, or proper patterns are used for distribution, different database for each microservices, and so on. So if you compare traditional service-oriented architecture with microservices architecture, whenever service orientation came into picture, the organization, the enterprise, always wanted to do something which they can reuse in multiple projects, multiple applications. And in the process of trying to do something for multiple projects, they always ended up spoiling the entire application. That problem did not happen in microservice because the focus was one application. Let us develop a service for this application. I'm not worried about another application that might need a separate service. It's okay. But applications-wide reusability was only achieved, not the enterprise-wide reusability. Service orientation calls were mostly synchronous. We'll make a call to another service method and wait for the response to come. What if the other service is not responding? This service also will become deadlocked. And the entire application can cease to work, as every thread is waiting for the other thread to complete the task and come back. Such problems were eradicated in microservice because microservices are supposed to use asynchronous communication. There should be something called as a message broker in between, where one microservice will post a message and the other microservice will retrieve the message. We used publisher-subscriber models, sender-receiver model for communication between services. So even if one was not responding immediately, it might respond after some time, but I will simply publish my message and I'll continue. I will not wait for the subscriber to consume. Later, sometime the subscriber can consume it. Programming style, imperative style of programming, whereas here it is reactive. Most of the time it is event-based communication in microservices. Because one product was added to the shopping cart, I might want to do something more. Or because the address of the person got changed, what should happen in other services? Reactive programming, callback driven functionality is supposed to be more predominant in microservices. Hundreds and thousands of lines of code was written to build a service. Here hundreds and very few lines of code is what we are supposed to write. Service oriented always ended up keeping state in memory. Microservices are considered to be most of the time stateless, preferred to be stateless. In service orientation, we always selected one database and all services would connect to the same database. The large RDBMS would be shared by multiple services. Every service will have a choice. It might use SQL Server, it might use MySQL, it might use MongoDB, NoSQL database. One service says, no, I want only Excel file. As per the convenience, the service can choose its own database option. So yes, net Here also services, here also services. But what has been understood is microservices are definitely not same as service oriented architecture. They are different. Microservice is an approach to the development where a single application is a suite of small services, and every service is running in a different process. Service orientation, all services can run in same process, and these services are communicating with lightweight mechanisms, like they might use REST API or they might do asynchronous communication, and every service is built on top of the business capabilities and deployed independently. Not necessary in service orientation it should happen like that. Actually speaking, microservices is nothing but service orientation done in a right way. That's the advantage of microservices architecture. Rather, today microservices is so predominantly used that even the user interface layers are microservices based. If you want to build a UI, you would simply do something like this. Header, you might have one microservice. Menu, one microservice. Left nav bar, another microservice. For each and every section of a page, there might be a separate microservice developed. So tomorrow, if I want to change something here, I just need to go and make changes here. I don't have to look at the other components. With different component based architecture, the entire page can be built. That's the beauty of the microservices based architecture. Good. But that does not mean everything is good. Definitely, there are drawbacks. Somebody has already asked in the chat, what if there are hundreds of microservices? Definitely, that's going to happen. Your project is going to have hundreds of microservices. Your functionality, every functionality, one microservice. So more the functionality, more the microservices. Microservices application, as I said, are distributed. Now, because they are distributed, quite obvious, lot of network hops are going to happen. More latency, delay in response. Communication has to happen using HTTP and AMQP, which are comparatively slow when compared to other native protocols. You have to compulsory write, because they are distributed, you have to write retry logic. And the worst problem is, where is the service? Is it on machine A or machine B or machine C? Where is it? Every service should be discoverable and moreover resilient. If one fails on one machine, it has to be recreated on another machine. That means the address has changed. How will this new address get reflected in the client? Client now will have to send the request to that location, not the previous location. If I explain more in detail, distributed applications are always going to add complexity for the developers. Every service is developed independently, good, but somewhere they have to communicate with each other. And this can increase the testing, that too with asynchronous communication. See, in synchronous communication, it is easy to do testing. I call the method, I get the response, I compare it with what I got. In asynchronous, I post a message, I don't get anything immediately. The receiver will receive the message sometime and then take an action, and probably it will post one more message which I'll have to receive and then compare with what is expected. This is endless. When will this happen? We don't know. It's not like a circle. It can take time. Writing test cases for microservices based application can anytime become very complex. You have to deploy dozens of microservices, and needs, that means deployment complexity is going to be there. You will have multiple repositories. When there are multiple repositories, there have to be multiple branches. Every repository should have its own pull request pattern created. Proper permissions have to be given. You need to have distributed application generating logs. Every service is running on different machine. How will I gather all the logs and see them at one place? Every service is versioned independently. Okay, good. But what is the version of the entire system? Distributed database makes transactions hard. Every service has got its own database. What if something should happen here and at the same time it should also happen here? How do you take care of this? Eventual consistency has to be taken care of, because you will not get distributed transaction benefit in microservices architecture. That has to be replaced with eventual consistent databases. You will have a cluster and the cluster will have to be managed, and that would require the orchestrator and advanced DevOps capabilities, and that is what is provided by Kubernetes. To most of the problems which are discussed here, the microservices problem, solution is used an orchestrator. What is orchestrator? If I take you to the browser, this fellow is the orchestrator. This fellow is the orchestrator. What is he doing? One stick, and is moving the stick. And it's based on this stick. The entire band is producing music. If not, the tabla, the violin, the piano. Imagine beautiful instruments and extraordinary people who are playing those instruments. Individually they are expert, but if they are not in sync with each other, what will happen? It will not be music, it will be noise. So whether that sound becomes noise or sound becomes music is in control of this orchestrator and his stick. They all follow him. Like that, to manage lot of these activities of microservices, especially the plumbing jobs, which are same in each and every project, we will need some kind of orchestrator tool, which can be Docker Swarm, which can be Azure Service Fabric, or it can be many more tools are there. The most popular of all the tool is Kubernetes. My next session is going to be on how does Kubernetes take care of these problems. Look forward to this particular session sometime in next week, maybe on the same day, same time, but the session is going to be extending this class on how Kubernetes takes care of a microservices based architecture. That's going to be another enlightening session about Kubernetes and why it has become so popular. That's all for today. Feel free to post your questions to me personally on the chat in WhatsApp or whatever way you can communicate with me. Also, my request would be, do give comments on how do you like this session. That is what is going to encourage me to come back again and again and deliver more such quality topics. That's the return which you are giving for the content and time which I am investing upon. At the same time, feel free to share these classes with your colleagues, with your friends. Put it on your channels. Tag me if you can. If you have a LinkedIn channel, post the link on the LinkedIn channel. The LinkedIn account. Tag me so that others can join this community and we can grow more. The more the number of people benefit, that will be more motivation for me to deliver the content. With this, I sign off today. Thank you and very best of luck to all of you. See you soon.